Bismillahirrahmanirrahim. Good morning, everybody. Today, inshallah, I'll revise with you chapter 17. Chapter 17. Chapter 17 from the very important chapters in chemistry. This chapter talks about acids, base, and salt preparation. Acid, base, and salt preparation. Okay, this chapter in your book in page 173. Page 173, chapter 17, acids, bases, and salt preparation. Okay, when I explained this chapter to you, I said to you, I want from you to know what does it mean by salt. Salt is a product from neutralization reaction between acid and base. And also salt is a compound produced from reaction between metal and acid, due to the displacement of the metal which take the place of hydrogen of an acid, like magnesium and sulfuric acid make the salt sulfate, magnesium sulfate, because magnesium take the place of hydrogen of the acid. Okay, so I want from you to know what does it mean by salt. As you see here, all acids, as we took in the last chapter, that all acids contain hydrogen. When the hydrogen is replaced by a metal, like magnesium, like calcium, like sodium, like any metal, compound formed is called salt, like magnesium sulfate, magnesium chloride, magnesium nitrate, and so on. So this is the salt definition. And also you have to know that salt come from neutralization reaction between acid and base. Here it is not a new information for you, but you have to memorize it well, that all acids contain hydrogen. We took it in the last chapter. You have to know what is the name of the salt. A salt of hydrochloric acid is called chloride. A salt of nitric acid is called nitrate. The salt of sulfuric acid is called sulfate. And the salt of ethanoic acid is called ethanoate, and the salt of phosphoric acid is called phosphate. Okay, this what we call the parent acid. Hydrochloric, nitric, sulfuric, ethanoic, phosphoric, this is the parent acid. And the salt produced according to the name of the parent acid. Okay, I said to you, you have to know here that metal below hydrogen in the reactivity series do not react, and I revised this chapter with you. But metal above hydrogen in the reactivity series react with the acid and produce salt releasing of hydrogen, because the metal take the place of the hydrogen of an acid and make salt releasing of hydrogen. Okay, this is an example. Metal and acid, you have magnesium and sulfuric acid produce magnesium sulfate and release of hydrogen. Clear? Okay, to change this equation into an ionic equation, I said it's easy to you here. It is another reaction between metal and acid. This is the same metal, magnesium and hydrochloric acid. It will produce the salt of acid, which is chloride, and release hydrogen, like here. The salt and release hydrogen. If you change the first equation from regular equation to ionic equation and cancel the spectator ions, which is sulfate, magnesium is still magnesium, and the hydrochloric acid will be hydrogen ion positive and sulfate negative. Magnesium sulfate will be magnesium ion positive and sulfate negative plus hydrogen. I can cancel the spectator ions, which are sulfate here, SO4 negative 2. And this is the equation. Magnesium plus hydrogen ion positive produce magnesium ion and hydrogen. And also the same equation when I have magnesium and hydrochloric acid, I'll split hydrochloric acid into hydrogen positive and the chlorine ion negative. Magnesium chloride will be magnesium positive ion and the chlorine negative ion, release of hydrogen. When I cancel the spectator ion, which is chlorine negative here and there, the equation will be magnesium plus hydrogen ion, produce magnesium ion and hydrogen. As you see, the same equation, I circle them for you to know that the reaction between the metal and the acid will be the same. It's actually reaction, displacement reaction between the metal and the hydrogen. The metal take the place of the hydrogen of an acid. Okay, here you have to know the reaction between zinc and two acids. Whatever hydrochloric acid or sulfuric acid, it will be exactly the same. Finally, instead of magnesium, I'll put zinc plus positive H ion, produce magnesium ion 2 positive and release of hydrogen H2. Whatever the equation, zinc and sulfuric acid or zinc and hydrochloric acid, it will be the same. Also in this chapter you have to know that the definition of bases here. Bases are substances can neutralize with acid. Here this is the definition as you see. He said bases are substances can neutralize acid, combining with the hydrogen ion of acid to produce water. Okay, and I said to you in the last chapter what are bases. You have the oxide, metal oxide bases, metal hydroxide bases, metal carbonate bases. Okay, so if you have metal oxide and acid, produce salt and water. Like copper oxide and sulfuric acid, produce copper sulfate and water. So here production of water is found when I have metal oxide or metal hydroxide. Like here I have metal hydroxide. I'm sorry, where is the equation for metal hydroxide? I think in another page. Okay, so here I want from you to know, as I said in the last revision, that the base may be metal oxide, metal hydroxide or metal carbonate. Okay, this is metal hydroxide. React with acid, produce salt and water. So metal hydroxide and acid, I want from you to know the general equation to produce salt and water, and the metal oxide plus acid produce also salt and water. Okay, carbonate also are bases. When I have carbonate, metal carbonate and acid produce salt and water plus carbon dioxide. All carbonate must give me in the product carbon dioxide. Okay, this is what I want from you. Okay, when I talk about the copper sulfate solution, the color is green. But if I talk about copper sulfate solution is blue. I said it a lot, blue. Okay, but copper carbonate is a solid powder, green. So if I have copper carbonate green powder with sulfuric acid, produce copper sulfate blue and water, release of carbon dioxide gas. Okay, also if you have sodium carbonate, the same with hydrochloric acid, it will produce the salt of the acid, which is chloride, sodium chloride, water and the carbon dioxide, not more. So it's better to memorize the general equation for the reaction between metal carbonate and acid, metal oxide and acid, metal hydroxide and acid, like this. Okay, and here we started to talk about salt and the solubility of salts. I said to you that you must memorize these two categories, which salt soluble and which is insoluble. I talk about solubility in water, okay, because as I said before that we have different solvent like organic solvent. When I talk about in the beginning, you have to know that any salt contain sodium, potassium, ammonium, it will be soluble salt. Any salt contain sodium, potassium, ammonium, it will be soluble salt. Okay, and all nitrate, if you find the suffix nitrate, the word nitrate in the compound, so the salt will be soluble. If you find the name sodium, potassium, ammonium, the salt will be soluble also. Okay, and we have that most of chloride are soluble except two kinds of chloride, lead chloride and silver chloride. And also the most of sulfate are soluble except the lead sulfate, the barium sulfate, and the calcium sulfate. Type. What about the insoluble salts? Most carbonate and most hydroxide. Most carbonate and most hydroxide are insoluble. Okay, except, what is the exception? If I have sodium carbonate, if I have potassium carbonate, if I have ammonium carbonate, it will be soluble. But most of the carbonate are insoluble. Most of the hydroxide are insoluble, except sodium, potassium, ammonium hydroxide. Okay, I said to you these points are very important. Memorize them because I'll give you about 8 or 10 salts and ask you classify them into soluble and insoluble salts. Okay, I said to you before that this preparation of copper sulfate crystal is important, okay, because it is يعني a practical point to know how we can make crystal. Okay, to make copper sulfate crystal, you will add copper oxide plus sulfuric acid to produce copper sulfate and water. Please, I cannot use copper itself because copper under hydrogen in the reactivity series, so it does not react with the acid. Okay, clear? I'll add the copper oxide with the sulfuric acid. It will produce copper sulfate with water. Okay, here I'll add excess from the copper oxide. Why excess? To be sure that all the acid is used up. And how I can remove this excess of copper oxide? By filtration. By filtration. Okay? Because any salt soluble except sodium, potassium, ammonium, we can add excess from the metal oxide or metal hydroxide or metal carbonate or metal itself if the metal is reactive. But in case of copper sulfate, I can't add copper itself. Okay, I can remove the excess from the copper oxide by filtration, and I start to heat the solution gently. Okay, why gently? Because I don't want to change it into powder, but I want to make it as crystal. What does it mean by crystal? Contain water of crystallization. What does it mean by water of crystallization? Number of water molecules chemically combine with the salt. Okay, and here el copper sulfate is a white powder, but copper sulfate crystal is blue, and we use it to test the presence of water, to detect presence of water. Okay, copper sulfate crystal is blue, and the formula of copper sulfate crystal is important. CuSO4 with 5 molecules of water. Okay, very important. And here I made copper sulfate crystal. Type. If I want to make magnesium sulfate, I'll add magnesium itself. No need to add magnesium oxide or hydroxide or carbonate. You can use magnesium because magnesium is actually reactive element. So magnesium and sulfuric acid produce magnesium sulfate and water. Okay, I want from you to know what does it mean by water of crystallization. Number of water molecules chemically combine with the salt. Okay. Here, when I heat gently and from time to time I'll hang a glass rod, I put a glass rod in the solution and then hang it in the air. When the drop change into solid, I'll stop heating directly. Because if I continue in heating, I'll remove all the water. It will be anhydrous without water, so it will be just powder from copper sulfate. But if I want copper sulfate crystal, I use gentle heating to keep the water of crystallization. What does it mean by anhydrous? From يعني logic without water, anhydrous. The word hydrate or hydrous, we use it to detect the presence of water. But when I say anhydrous, that's to say there is no water. Okay, I wanted this. And here it is a reaction between hydroxide and acid. It's also a neutralization reaction. Okay, how I can make salt? I want from you to memorize well the summary here. When I ask you summarize the methods of making salt, you will write this for me. Okay, in the beginning, if the salt is not soluble, I use precipitation method. And don't say precipitation method and stop. You have to say precipitation method by adding two solutions. One contain positive ion and one contain negative ion. This if the salt is insoluble. What about if the salt is soluble? If the salt is soluble, maybe one of the two categories. Maybe sodium, potassium, ammonium salt, so I'll use titration and say titration and stop. But if it is not sodium, potassium, or ammonium salt, any soluble salt, like copper sulfate, I used copper oxide with sulfuric acid. Like magnesium sulfate, I used magnesium itself with sulfuric acid because magnesium is reactive. So we can react excess amount of the metal itself, metal oxide, metal hydroxide, or metal carbonate with a dilute acid, like this. So this summary is very, 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 very important. Okay, like this. How you can prepare salt these ways. What are soluble and insoluble salts? These 6 points. I'll ask about them. How I can make crystal from copper sulfate. How I can make crystal from magnesium sulfate, adding magnesium itself. But in this case, I cannot add copper itself because it does not react with acid. It is under hydrogen in the reactivity series. Okay, this summarized here. And then I want from you to know what is the definition of acid and base. Okay, we have a theorem in explaining the acid and the base. I'll give you information about this theorem. We have Arrhenius theorem. He explained that all acids contain hydrogen ions. It's okay. And he said all bases contain hydroxide ions, OH negative. Okay, but he didn't know how can explain the reaction between hydrochloric acid and ammonia. Ammonia is base, as I explained to you in the last chapter revision. Ammonia is base, but does not contain hydroxide ion negative. Okay, he failed to explain the reaction between hydrochloric acid and ammonia as an acid-base reaction. Okay, but Bronsted and Lori, these are two scientists, explained to us that another definition that all acids contain hydrogen ions. It's okay, produce hydrogen ions. It's okay, and the bases, we can say that the acids are hydrogen donor. okay, is a supplier of hydrogen ions, but base is the hydrogen receptor. Important definition. Base hydrogen receptor. The thing receive the hydrogen of an acid, we call it base. Okay, like this. I want from you to know that we have what we call hydroxonium ion, which is H3O negative 1. This is appear when you dissolve acid in water. Hydroxonium ion. Okay, these kinds of reaction, as I said to you, the reaction between ammonia and hydrochloric acid is an acid-base reaction. Acid-base reaction. Why? Even ammonia does not contain hydroxide ion, but ammonia is a receptor for the hydrogen produced here from the acid. So here is a hydrogen donor and here hydrogen receptor. Okay, all kinds of these reactions, I'll give you equations and ask, decide if these reactions are acid-base or not acid-base reaction. Like this, as you see here, you have, say, مثلا nitric acid and water, which act as an acid, which act as base. Acid, nitric acid and water here act as base. And here you have مثلا الأمونيا, and here we have H. According to Bronsted and Lowry, the hydrogen donor is acid and the hydrogen receptor is base. Okay, these kinds are important. Yes, plus I show you this when I explain the lesson, and I want from you to, I'll make copy from these reactions and give them to you. Here, as you see, I have aluminium and hydrochloric acid. Of course, it is not an acid-base reaction. Already I have acid, but where is the base? I don't have base. Okay, I don't have base. Aluminium is not base, so it is not an acid-base reaction. Like this, another equation, not acid-base reaction, like zinc and copper, zinc atom and copper ion. It is not an acid-base reaction, but all other are acid-base reaction. Like here, magnesium oxide, and this is metal oxide and acid, so acid-base reaction. This is the acid and this is the base. Carbonate plus hydrogen, this is from acid and this is from base, and we said that aluminium is not base, so this reaction is not acid-base reaction. Water and hydrochloric acid, this is the acid and water acts here as a base. Zinc and copper is not an acid-base reaction. NH3 ammonia, I said a lot that ammonia is base, hydrogen receptor, and the hydrochloric acid, so it is an acid-base reaction. And we have hydroxide. This is base, and the hydrochloric acid is an acid. Okay, so I want from you to know this. I answered the question with you when I explained the lesson. These only the questions I want from you. To classify the kinds of salts, important question. Soluble or insoluble, like this. Okay, to decide the reaction is acid-base reaction or not, like this. Okay, and how we can make salts. Very important things. Thank you. Best wishes.